So in this tutorial, we'll cover the remote validation against a IMEX 8M Plus target on both the CPU and the NPU. So as a recap, the way DeepView Creator and Model Tool interface remotely with the target is through the ModelRunner server, which is a HTTP API server, so basically a web service. And this service interfaces with the ModelRunner C API, which in turn has a plugin API to interface with all the various EIQ engines. So it provides a common programming interface for DeepViewRT, TFLite, ARM&N, ONNX, and it also works on MCUs for TFLite, DeepViewRT, and Glow. On this, we'll focus just on the HTTP API and how we use that from DeepView Creator. So first, we'll show how to install it onto the Linux target, and then we'll launch the server with a couple of the inference engines backends, and then we'll go run the remote validation. So first, on the NXP community forums, you probably came to this post to find the video. So again, there's a description of the installation process, so you can follow that, but we'll quickly go through it here. The video walkthrough is obviously not up yet. So if we click here to download the attachment, and then we'll switch to the terminal. So in my case, the 8M Plus target is at this IP address. So SCP it over it and SSH the target. So once you do this, first thing is you can just go ahead and run ModelRunner -v, and we'll just confirm that it runs with the base plugin. So by default, if you don't give it anything else, it'll be the DeepViewRT plugin. And here we see that it loaded DeepViewRT 2418 and that the ModelRunner service, so this server and library are the version 2013. So to start the HTTP service, basically you give it the capital H and then a port number. You can run a few of these with the different backends. So to start, we'll run the base version. So this is DeepViewRT on CPU on the port 10818, and then just open a couple tabs here. And then we'll run another one for the OpenVX. So this is the DeepViewRT NPU implementation, and the plugin is just referred to as OVX. And in that case, we'll just run it on the next port, so 10819. And then finally, we'll go launch TensorFlow-Lite as well. This one will run on 1020. Okay. And then we'll come back and run another TensorFlow-Lite with the NPU, but we can only have one engine using the NPU at any given time. So we'll start with the DeepViewRT and we'll show the workflow like this. In the later tutorial, we'll do a little bit more of a sort of breakdown comparison across the various engines and see the performance and capability differences. But for the purpose of this, the three different variations at target should be plenty. So now in DeepView, I'll open up the cars project. So this is just a little toy car demos, or toy car data set. And then we'll pick a model that's already been trained. So we can pick load previous model, and we have this detection performance model that we've trained. And as you can see, the epochs, the detection models take obviously quite a while to get decent accuracy, but we'll load this up. And you can see the training graph here. Interesting progression of accuracy, and then the loss is maybe a little bit more, as you would expect. And well, we're not training, so we can't see that. So we'll skip over to validation. So to set up our targets, there's the validation target button here. So if you were to just start by running validate, this will run the validation locally. So this just runs on the PC. You're able to adjust the quantization parameters and run all that, and it runs on the PC. And in the quantization tutorial, we'll go over what all these means and how to interpret the results. But for now, we'll go run. We'll show how to set up the target. So if we pick a validation target, we've pre-populated them over here. So the 8M plus CPU TFLite, and then the port 10820. So if I go back to the terminal here, you can see the TFLite was on the 10820. So if we click it, click OK, and we'll see over here on the target name, you'll just see the ... But if you mouse over, it'll show you the 8M plus CPU TFLite, and then I'll show you the URI, so IP address and port number. So on the PC, our accuracy float. So float. We expect the exact same accuracy on the target. So it's 78 and a third. It's tiny data set, 35 samples. And then the model evaluation time on the PC is about 3 milliseconds. So now if we go run validate, there we go. So accuracy is remained the same, but we see the model evaluation time is a fair bit higher. Now it's pretty decent PC. And then so 76 milliseconds for the detection model is pretty decent. We'll see on the NPU we can get even better performance. Some glitches here that you can see. So the total overhead time. So total overhead, the idea is that the total validation time, it took 10 seconds to run validation, and we have a breakdown of all the pieces we measured, and then whatever's left is meant to be the overhead, which clearly is not being calculated correctly over here. So that's one we'll have to fix. But otherwise, that's TensorFlow-Lite. So if we wanted to compare the performance, same model, and again accuracy against the DeepViewRT on the CPU. So now the 10818. So again, if we go back to the terminal, it was on our first tab here. 10818 is on the DeepViewRT. So if we click this target, click OK, and then again, mouse over here, make sure it's the right target, and then click validate. So again, accuracy, float models, there should be no difference between the models. And then we can see the evaluation time is roughly half, or a little better than half the processing time. So that gives us an initial performance boost, but still running on the CPU. And then finally, since it's the 8M Plus, what we're really interested about is the NPU. So if we go to the middle tab here, we see it was on the 10.8.19. And then if we pick our validation target, and then the NPU, so 10.8.19, okay. And again, just double check the port. So now if we click validate, we would hope that the performance is going to be pretty good. But we can see right off the bat, it doesn't look that fast. So it's actually not that surprising. The float models on the NPU are a fair bit slower than the processor. And that's not really what the NPU is for. So let this finish and just see the numbers. But then we'll go and quantize this model to really get the good performance. So 284 milliseconds. So it's nearly 10 times slower than DeepViewRT was on the CPU. The accuracy, accuracy went up a bit, but that's a quirk again. Samples 35. You can be incorrectly right about an answer. If you want to start comparing, quantization accuracy, which we'll do in the quantization tutorial, we'll use a bigger data set that actually has some, that's more representative of the loss from quantization. But to quantize, all you got to do is turn on the post-training quantization. So this is a detection model. Detection models are all post-training quantization. The quantization-aware training is currently limited to the classification models. And then we can pick per channel, per tensor, and the input-output data type. So per channel is kind of what is typically the default in more modern times. It just gives you more, better granularity on your quantization parameters. And then input data type just refers to what you're going to feed into the model and out. So the models are still trained as floating point, and by default the inputs and outputs are float. But if we're quantizing, you probably want to deal with the integer data directly. So for example, if you have your camera frame is going to be uint8 pixels, and you can feed those directly into the input. So we'll leave that as uint8 per channel, and then we'll go ahead and click validate. So I've run through this before, so it goes right to the model upload. If you haven't quantized the model yet, you'll first need to do that, which can take a little bit of time. But be patient; it'll eventually complete. It can take a couple minutes depending on the speed of your processor, but eventually it'll complete and it'll run. And now we see there is some loss in accuracy. Again, don't read too much into this with this data set, but and now we see the performance is greatly improved. So now 5 milliseconds, so about 6 times faster than our CPU numbers for this detection model. And then on the NPU, we actually get even greater performance from the per tensor. Now there's trade-offs, and we'll go over those again in the quantization tutorial. But don't be surprised if this number goes up. Again, 35 samples. So we'll switch to per tensor quantization. Click validate. Again, it was already quantized, so it goes through right away. Sure enough, accuracy went up, which is kind of the opposite of what you would expect. But timing is the same. Like regardless of your accuracy, the timing doesn't change. So we see an even bigger boost in the performance. So the per tensor quantized models see the best performance on the NPU here. So that's that's the remote validation. Related to that, I also mentioned the model tool. So if we take a quick peek at that, click done over here, and then from the export screen, we can export a DeepViewRT model. You can enable the quantization. Kind of all the same parameters are here again. And then we'll just go on the NPU. Currently, there's no layer by layer timing information, so we can go look at how it looks. So we'll do our per tensor, uint, export. And then I just pick the default file name there. And then once you do that, you can open the model, which opens it up in the model tool. So under tools, there's manage targets. So if you click this, I've already put these in for the NPU, CPU. And then you don't need to type in the HTTP and V1. You just type in the IP address, and then give it a name. So I've done that already, and I've already got NPU selected. You can select, multiple devices, and it'll profile them both. So say I want to compare like how my PC performs against the NPU. It's going to look, the NPU is going to look pretty phenomenal in this case, but that's okay. We'll show the comparison. So you turn these on and off to get that attached. That's to attach to an already running target. So we'll just leave it like this, and then runs 10 runs, which means once it uploads the model to the device, it's going to run the model 10 times and collect the timing information. You can crank that up or down depending on what you're doing. So we'll close that. Now we'll go and just click Profile Model. So there we go. It happens pretty quickly. And then under View, there's a Show Timings option. So if you go ahead and click that, we see the timing information now shows up. It'll show up for all the different targets that we ran. So we ran PC and NPU, so it shows all those timings. And as we can see, the PC is reporting layer by layer timing. That's because it's running DeepViewRT on the CPU, and it's able to measure it. For the NPU, currently only the overall graph. So if you click the input node here, this actually gives you the timing information of the whole the whole model. So we can see again, there's the 4.5 milliseconds on the NPU. As I mentioned, the PC looks a bit slower here. Now the PC though, it's getting that same quantized model. It's actually just emulating the quantization there, so it's not really a performance gain. But again, NPU is what we're concerned about, so we can see that there. And then if we wanted to go, say, look at the CPU numbers again, turn this off. The reason I'm turning this off here is on the ARM CPU, the float performance is actually quite good. So we typically do that there, where we're not really constrained by memory so much. And in fact, the DeepViewRT memory usage, even with float models, is quite low. What's going on here? Looks like did I forget to click export? Yes, I did. Okay, there we go. And then open model. There we go. There's our float model. And then I'll go under the manage targets. And sure, I'll leave the PC on. But now I'll turn off NPU, and again, instead go on the CPU. And tools, profile model. And you can use this across a few targets as well. So say you wanted to compare distributing the same model to a couple different inference engines and compare their timings. Use different targets, obviously, so they're not interfering with each other. But you can have 2-3 targets and just give them all different IP addresses, just like we have PC and target running here. And then again, view show timings, and then we can start looking at the layer by layer timing. So click input 1, we can see the timing. So my PC, so again, like it's actually quite a bit faster with the full model now. And then we see again the 8M plus CPU number was the 30 milliseconds. And then if we had two targets, probably a more interesting one is if we wanted to compare layer by layer timing between TensorFlow Lite and DeepViewRT and see like, okay, overall DeepViewRT is about twice as fast, but you know, where is it fast? Is it all the layers, some of the layers? We can go and kind of dig through this. The color coding, make the window a little bit bigger. Color coding is just so it stands out. You know, when you zoom out and you're trying to look at where these hotspots are, and then the percentage refers to just the how much of the overall model time does this layer represent. So this first layer takes on the PC 22% of the time, and on the 8M plus takes about 11% of the time. And then we can go through and look at some of the other ones. Things like reshape, they're in the graph, but they don't actually take any time. But there we go. That's the remote validation and profiling. I suppose a quick touch on the quantization, but we'll have a separate tutorial where we dig in more of the details of the quantization and some of the limits around that. Thank you for watching.